Welcome to Bot Thoughts by AmtocSoft. I'm Alex, and Sam is here as always, our resident AI systems expert. Today we're talking about something that trips up almost every developer who tries to build a real AI agent: state. Specifically, we're talking about LangGraph, the framework that brings actual state machines to AI agents. Sam, quick framing question: why isn't LangChain alone enough for serious agent work?
LangChain is excellent at chaining together sequences of LLM calls, but chains have a fundamental limitation. They're linear. You call step 1, then step 2, then step 3, and you get an output. Real agents don't work like that. Real agents need to loop. They need to try something, evaluate whether it worked, and try again if it didn't. They need to branch, take different paths depending on what they discover. And they need memory. They need to carry context across multiple steps without cramming everything into one enormous prompt. LangGraph adds all three of those capabilities on top of LangChain's primitives. It lets you define agents as actual directed graphs, where nodes are processing steps, edges are transitions, and a persistent state object flows through the whole thing.
Okay, so we're literally talking about a graph, like nodes and edges, the data structure kind of graph.
Exactly that. A directed graph where each node is a Python function. It takes a state object, does something, and returns an updated state object. Edges define where control flows next. Some edges are unconditional. Node A always goes to node B, others are conditional. After the LLM responds, if it decided to call a tool, go to the tool node. If it decided it has an answer, go to the output node. The state object is a typed dict, a Python dictionary with a fixed schema that you define. Every node reads from it and writes back to it. That single shared state is what makes agents coherent over time. Instead of passing context as an ever-growing string, you have structured data that every part of your agent can access cleanly.
So LangGraph and LangChain, these aren't competing frameworks. They work together.
LangGraph is built on top of LangChain. You still use LangChain's LLM integrations, prompt templates, output parsers, tool definitions, all of that. LangGraph adds the orchestration layer, the graph structure, the state management, the checkpointing system. Think of it this way: LangChain gives you Lego bricks, individual components you can snap together. LangGraph gives you a blueprint for how to arrange those bricks into a machine that can actually loop, branch, and persist. The key addition in LangGraph is the concept of a checkpoint. After every node execution, LangGraph can serialize the entire state to storage: SQLite, Redis, Postgres. This means your agent can be interrupted and resumed. You can run the first 3 steps of a research task on Tuesday, pause it, and continue from exactly that point on Wednesday.
Let's make this concrete. What does a real LangGraph agent actually look like in code?
The classic pattern is what's called a RAACT agent: reasoning and acting. You define a state with 3 fields: messages, a list of tool results, and a counter for the number of steps taken. You create 2 nodes, an LLM node and a tools node. The LLM node calls your language model and appends the response to the messages list. Then a conditional edge checks: did the LLM call a tool, or did it give a final answer? If it called a tool, the graph routes to the tools node, which executes the tool, appends the result to messages, and loops back to the LLM node. If the LLM gave an answer, the graph routes to the end node. That's it. That's a RAACT agent. About 40 lines of Python. And the really important part: you can add a checkpointer in literally 2 lines. Pass a SQLite checkpointer to the graph's compile method, and every state transition is now automatically persisted to disk.
You mentioned interrupted and resumed. That brings up something I hear a lot: human in the loop. LangGraph is supposed to be good at this. What does that actually look like?
Human in the loop is one of the most important practical features LangGraph adds. The mechanism is called an interrupt. You can add an interrupt before any node. It means, before executing this node, pause and wait for human input. The state gets serialized, the agent suspends, and your application can present the current state to a human in a UI. The agent wants to call this tool with these arguments: approve. The human reviews, approves, or modifies, and resumes the agent. This is critical for production systems where you don't want an AI agent making irreversible decisions, deleting records, sending emails, executing code, without a human sign-off. And because LangGraph's checkpointing is graph-aware, resuming is instantaneous. You don't re-execute any prior steps. You pick up exactly at the interrupt point.
What about multi-agent systems? Can you compose multiple LangGraph agents together?
Yes, and this is where LangGraph gets genuinely powerful. There are two main patterns. The first is a supervisor pattern. You have a supervisor agent whose job is to dispatch tasks to specialized subagents. The supervisor sees the overall goal, decides which subagent to call, hands off a scoped task, gets back a result, and decides what to do next. This is the pattern you'd use for something like a research agent that has one subagent for web search, another for document analysis, another for code execution. Each subagent is its own LangGraph graph. The second pattern is peer-to-peer. Agents communicate directly with each other through a shared message queue with no central coordinator. Both patterns are supported natively in LangGraph. Subgraphs can even be compiled independently and reused across different parent graphs.
Let's talk about the state management more. The state schema is that rigid. Can you change it once deployed?
The state is a typed dict in Python, so it's typed but not externally validated by default. You add pedantic validation on top if you need it. Changing the schema after deployment is where you have to be careful. If you've persisted checkpoints with an old schema and then deploy a new version with a different schema, those old checkpoints may not deserialize correctly. LangGraph doesn't have automatic schema migration built in. The practical approaches are: use additive-only changes to the schema. Adding new optional fields with defaults won't break existing checkpoints. Or version your graphs explicitly. Name your graphs with a version suffix and route old sessions to the old graph until they complete. This is the same problem you'd face with any stateful system, but it's worth planning for before you hit it in production.
What does streaming look like with LangGraph? Users expect to see output streaming in, not wait for a full response.
LangGraph has excellent streaming support. There are 3 streaming modes. Token streaming. Individual tokens stream from the LLM as they're generated, which is what most chat interfaces show. Node streaming. Events fire as each graph node starts and completes, so you can show the user now searching the web, now reading document, now generating answer. State streaming. The full state object is emitted after each node completes, which is useful for debugging. In practice, you usually combine token streaming for the user-visible chat portion and node streaming to update a progress indicator. The API is an async generator. You call a stream on your compiled graph, pass an input and a config with a thread ID, and iterate over events. You can filter by event type to get just what you need. This design works cleanly with frameworks like FastAPI, where you can stream directly to the client using a streaming response.
Persistence seems like a key feature here. What are the real-world checkpoint backends people use in production?
LangGraph ships with 3 built-in checkpointers. SQLite is perfect for local development, 0 dependencies, everything in a file. Memory checkpointer stores state in RAM, great for testing, nothing persists across restarts. And the Postgres checkpointer, which is what you'd use in production. LangGraph Cloud, LangChain's managed hosting service, handles all of this for you. But for self-hosted deployments, Postgres is the standard choice. The thread ID is the key concept. Each distinct conversation or task run gets a unique thread ID, and all checkpoints for that thread are stored together. You can query checkpoints by thread, replay a run from any intermediate state, or fork a thread, take a snapshot at step 5 and branch into 2 different continuations. That last capability is incredibly useful for A/B testing different agent behaviors from the same starting state.
What are the common mistakes developers make when they first start building with LangGraph?
3 big ones. First, mutable state bugs. Because all nodes share the same state object, if you're not careful about how you update it, you can get subtle bugs where one node's changes affect another in ways you didn't expect. LangGraph uses reducers, functions that merge new state with existing state, and if you don't define them correctly, you'll get unexpected behavior. The pattern is, always return new state, never mutate in place, and be explicit about how list fields get appended versus replaced. Second, infinite loops. If your conditional edges have a bug, the agent can loop forever between 2 nodes, burning tokens and money. Always add a step counter to your state and a hard limit on how many steps any single run can take. Third, checkpoint bloat. Every step writes to the checkpoint store. For long-running agents with large state objects, that adds up. Set a TTL on your checkpoints and periodically clean up completed threads.
Is LangGraph Cloud worth it, or should teams self-host?
Depends heavily on the team's infrastructure capacity. LangGraph Cloud gives you the full stack out of the box: Postgres persistence, streaming API, monitoring dashboard, deployment tooling. For teams where the engineering cost of running stateful infrastructure is higher than the subscription cost, it's the right call. For teams with strong platform engineering, self-hosting is straightforward. Run your LangGraph server as a fast API service, pointed at a managed Postgres instance, deploy on any container platform. The LangGraph server package is open source. What you lose with self-hosting is LangChain's Langsmith integration depth. The managed version has tighter tracing integration. But Langsmith itself is available as a standalone service that works with self-hosted LangGraph perfectly well.
How does LangGraph compare to other agent frameworks? Autogen, CrewAI, plain function calling.
Plain function calling, OpenAI tool use, Claude tool use, is the foundation that all frameworks build on. It's the right choice for simple, single-turn tool use patterns. LangGraph adds the orchestration layer when you need multi-step, stateful looping behavior. CrewAI is opinionated. You define roles and crews, and it handles the orchestration. It's faster to get started but less flexible when your requirements don't match its mental model. Autogen from Microsoft takes a conversation-centric approach. Agents communicate through a shared message bus. It's excellent for collaborative, debate-style multi-agent setups. LangGraph is the most flexible but requires more explicit graph design. It's lower level than CrewAI and Autogen, which means more control but more responsibility. For production systems where you need fine-grained control over state, interrupts, branching, and persistence, LangGraph is typically the strongest choice.
All right, 3 things to act on this week for someone who wants to actually use LangGraph.
First, build the React agent tutorial from LangGraph's own docs. It's 40 lines of code and will give you a concrete feel for how nodes, edges, and state interact. Don't skip it, actually run it. Second, add a checkpointer to that agent and call it twice with the same thread ID. Watch the agent remember its prior context across the second call. That moment of seeing persistence work is what makes the framework click. Third, add an interrupt before your tool node. Put an approval step in. Run it and actually approve an action from the console. Once you've felt that pause and resume flow, you'll immediately see which parts of your production agents should have a human review step. Those 3 exercises will take you 2 hours and move you from "I've heard of LangGraph" to "I can design a production agent architecture." For a full code walkthrough, our latest blog post covers this in depth. Link in the description at AmtocSoft.blogspot.com.
That is exactly the kind of hands-on progression that actually builds intuition. Sam, great episode. For everyone listening, full code examples and a deep dive on LangGraph's state management and checkpointing system are in the blog at AmtocSoft.blogspot.com. If this episode helped you understand stateful agents better, please subscribe on YouTube or wherever you get your podcasts. It genuinely helps us keep producing content like this. And if you want to support what we're doing at AmtocSoft, you can buy us a coffee at buymecoffee.com/AmtocSoft. I'm Alex, Sam's been Sam, this is Bot Thoughts. See you in the next one.